Joel Griffin. Hi, everybody. I'm with you now. I'm here to talk about the San Juan Water migration into the utility network. And this involves several pieces of integration, one being the CMMS, the Cityworks system that we brought in, along with the Esri utility network. And the utility network, as some of you might have heard, is a new solution from Esri to network your water system, or electric or gas. There's other ones too, but in this case, it was just the water system. And to get that to be into a system that's now used by everyone throughout the district. It's not just used by GIS analysts or certain people that just with GIS skills. It's now shared. This service is shared with everybody, including Cityworks. And so everybody's able to do any sort of maintenance and inspection reports off of those GIS features. The key component of the utility network is that it is a service-based architecture. So when you do any edits or doing any sort of editing or anything that you're interacting with the data, you're actually doing it on a REST service, which is a lot different from the way it used to be for us in the GIS world. We used to have to deal with a native client connecting directly to SQL through ArcGIS Desktop. And once you do the utility network, what you do is you set that up through the native client, and then you publish it. And then from then on, all your analysts and the viewers are working directly on the REST service itself. So this is a sea change in how we operate in the GIS world. And this helps to get the data to the people that need it a lot quicker, instead of having previously maybe a replica database that's published out to your REST services, or maybe even just a checked out shapefile. You now can directly connect to it, and you connect all the permissions and everything through Portal for ArcGIS. So that's a few of the caveats. You have to be on Enterprise as of now. They're planning on doing some migration work into ArcGIS Online in the future, but right now it's just ArcGIS Enterprise. So I'm going to talk a little bit about the quick facts about San Juan Water District, a little bit about the story, and I'm not going to get into too many fine-grained details about the utility network. There's a ton of great videos that Esri provides, but I'll get into a little bit about the setup. And I'm talk a little bit about some of the additional things we had to do for Cityworks to make sure that everything talked nicely with the relationship classes and everything, and then talk about the conclusion and how everything all fit together. So San Juan Water District was established in 1854, been around for a while, serves the community of Granite Bay and portions of Roseville, Folsom, and Orangeville, California. As you see from the map there, just outside of Sacramento, California. They have a retail service area, consists of 17 square miles, serving about 12,000 customers, and about 200 miles of pipeline, wide-ranging diameters, due to the fact that they sell some of their water to wholesale customers downstream. So some of the other sister agencies downstream get the water from the water treatment plant that's connected to the Folsom Lake, as you see there in the map. And they have about 50 employees there. And what we did is set up an enterprise license agreement with Esri. So we now have 50 named users for the enterprise system. So anybody that wants to go in there and contribute, make edits, they're able to do that. So this is a little bit about the needs assessment that we did to start out. We wanted to identify all the other supported systems that we wanted to connect to, and also make sure that we have a system that we build that it's not just some special custom developer system that cannot be maintained in the future. We want to make sure that there's something using Esri software and some other custom widgets connecting things here and there, but mostly out of the box configurations that we could use just to customize their needs, but still using the base functionality and the base software. And we want to be able to integrate with CMMS and hydraulic model and their customer information system. So bringing all these pieces, they started in CAD, bringing that CAD environment. It's not very shareable or usable by other people. So we're bringing that into the GIS environment, where it's now the center of all the information that the district needs. We also wanted to bring in the document management piece, where all these hanging files and big flat files that were hanging up in the map room are now digitized and scanned and available in the web map that the field service crews can use. We want to make sure that everything in the system is secure, so everything's all within their network. It's all hosted internally. You have to have network access to see any of the data or act with anything in the system. Some of the project highlights, oh, too fast. Some of the projects highlights included bringing in CAD to GIS. That took about 4 months. Again, I mentioned about 200 miles of pipeline. Converting that from CAD to GIS, we did a few things at the beginning to get that set up, just for alignment purposes, bringing in the parcels from the publicly available parcels from the 2 counties that it sits on, and then line that up before we migrated it into GIS. And then we brought in the water solutions package from Esri for the water distribution to kind of start with the base schema, and I'll get into that in a second. But we did some other things, setting up the will serve applications and project tracking is something they used to do through Excel tables and access databases that were separate. People had their own versions on their own machines. I'm sure you all been through that. And we brought that all into the GIS system. So now when somebody in engineering makes a change, somebody in customer service can see that change and get that information and use it right then and there. And there's a few other things like that we did to integrate together, bringing in the customer information systems, the Tyler table, so all the customer information, like the addresses, last inspection date, the consumption for that last inspection, all brought into the GIS system. So again, the field service crews can see that in customer service as well. And that graph there on the right showing how GIS really is the center of all this information. And I consider GIS really the key component of it being a communication piece. So this is the implementation scope. I'm not going to get into everything here. The highlighted ones are really the big time consumers. So you had the migration, took a lot of time. Getting the meters and customer information location set up took a little bit of time too. Scanning all those documents took a long time. The plant and SCADA locations, that didn't take a lot of time, a lot like what Scott showed before. They had a sketch of the plant and what they wanted to do. We digitized that. I'll show that a little bit later as well. But to get all those pieces together and make sure we have the right systems within the right process areas and things like that. I think David's on the call there. He can tell you all about it as well at San Juan Water. We took some time going through that and making sure we had all the pieces put together and configured it. Once we had the draft version, configured it a little bit differently, a couple iterations, and got that set up. And then once we did all of that, we had some training classes. We went over all the GIS data, so all the field crews are very aware of everything that we had in the system. And then we're rolled out Cityworks after that. So they're already very familiar with the data that's already in the maps. And Cityworks just consumes that same data. So they're already very familiar with the data in the maps and how everything looked and felt before they even started really working with Cityworks. Get this thing to go here. All right, so setting this up. As I mentioned before, we had ArcGIS Enterprise 10.7, so you have to be on Enterprise as of now to use the utility network. We're on ArcGIS Pro, so again, this doesn't work in ArcMap. You have to go to ArcGIS Pro if you want to start using the utility network, and I highly recommend you do anyway. And once you have Pro set up, then you can use this ArcGIS Solutions deployment tool, install that, and you can download any of these utility models that you see here on the right. Again, this is just water that we're showing. There's ones for electric and gas, and there's ways to even interact your electric features with your water if you so wanted to have that modeled within your network. Then once we have all that set up, we add the utility network pieces, import the CAD features into that GIS schema for the water distribution, and then we publish the map services. What it does is creates a feature and map service. So the feature is what you give to the GIS analyst to do all the editing, and the map service is what you publish out to all the field crews. So they just see the data. They're not editing it or actually changing it in any way. And then we add rules or subnetwork configurations for any rules. That took a lot of time too. Once we loaded everything into the utility network, there's a ton of network errors because of simple things, and there wasn't rules for ARVs or BOVs in the water network. So we simply added those rules in and then did another validate, and that made the network accept it and cleaned up all those errors. Then last but not least is cleaning up the subnetwork tiers. And this is a big piece to the utility network, and the big power behind it is having these subnetworks set up. So you're able to set up like your pump zones or PRVs as your subnetwork controllers. And then you can see all the water that goes down from that location or back up to it, and everything in between. If you have an isolation event, like a reported leak or something like that, you can click on a point on the map where that location is, and then it'll automatically go out to the nearest valves and tell you which ones you need to shut off right then and there. And that network capabilities can be transferred to the web browser as well. So you can have a tool set up in your web browser that the field crews can run right then and there out on the street. And to go a little bit more into some of the benefits and functionality of the utility network, as I mentioned before, the flexibility of being a feature service. This more and more we see third-party vendors and other people that are able to connect directly to this feature service. You don't have to worry about a geodatabase connection issue or even them hitting it directly. They're just looking at a view of it from that map service. And it's a lot more flexible and easy to use for other parties now, a lot more than it used to be. And having that flexibility, you can set up your editors so they can do their edits in the field if you wanted them to. Having that productivity, being able to do that in any place on any machine is very powerful. And the quality that you get on using these rules with utility networks, so you can't have a water hydrant connected to a service lateral. It has to be a certain hydrant or fire service lateral that it's connected to. Things like that are set up on the front end help your editors have a more quality product. You don't have to spend a lot of time QA, QCing, and cleaning up stuff. And there's a lot of these feature templates that are built into it, so you can have a whole valve construction set up in your editor toolbar. So with basically 2 clicks, you can add in a service main with several service valves on top of it, even a BOV or anything else that you want to add on top of it. You can create these templates. You can create a whole pump station with these templates with basically 1 click of a mouse once you get it set up. So there's a lot of those workflows that really help the functionality and benefits and productivity of all of your workers. The network modeling is, of course, the key component to the utility network, hence the name. And so, like I was mentioning, the sources, so things like your pump stations, your water treatment plant would be your sources. It establishes the connectivity, so it knows whether things are connected or not, and that will enable the tracing, of course. There's these other concepts of containment, so you have these devices, kind of what Scott was talking about, maybe any valve or a piece of equipment within a certain part of your water treatment plant, it can be part of that container. So anytime you select that process area in your map, all those things that are part of that containment are also connected and show up. So if you run a trace, you can also pick those items out. And attachment is something else that we use mainly for items that are maybe, like for electricity, they use it for poles. So things that aren't actually part of your electric network, but your transformers are attached to those poles. And so you can model that within your network without actually having to draw lines to show that relationship. And of course, the tracing, there's several out-of-the-box connected subnetwork, upstream, downstream isolation, shortest path traces that are set up. And there's a ton of functionality just within it's a geoprocessing tool. So you can configure that however you want it, save it, and you publish that up, and it goes straight up to the web. And the 3D visualization piece is really big that we're starting to get more and more into, seeing some of those drawings that Scott had earlier of all the different pipes going within the water treatment plant, being able to visualize that. It's all built in the native structure of the utility network being a 3D feature. Then schematics is something that I've seen more and more of people using recently, It's just another way of seeing your data and simplifying it. Instead of seeing every single valve that's on a main line, you maybe just want to show a diagram of all the PRBs and all the hydrants or other small things that make up your network that you want to show, and you can configure those schematics to display and be used by your engineering group and print them out if you want, or publish them and use that however you see fit. There's a ton of benefits, and I'm not going to have enough time to go through everything here. I do recommend, if you guys are interested, going to some of those Esri videos to see how some of the other functionality live and direct. I'll get into a little bit more here, but it's really interesting to use. And yes, there is a learning curve to get started, but once you get going, you get used to it. It's just like most other GIS features you're used to working with, points, lines, and polygons. They have some rules and some intelligence behind them, but they're not hard once you get used to it. So here's what it looks like when you open up Pro. This is the water distribution project for Naperville. So this is some demo data that we use, and you'll see here the network structure there on the left. I'm sorry, it's kind of hard to see, but what I'm trying to show is there's really only 9 different layers that are part of the utility network here, and that's huge because you don't have to manage 50 different layers for all the different pieces of your water network. It's all consolidated within 9 layers. So this makes it a lot faster for web mapping, for just doing panning, zooming, and desktop, and being able to query on inspections for your entire water device feature class instead of having to go one by one. And the other thing I have highlighted here is the UN data set, and that's what highlights all the errors and things like that you see when you start validating your network. That helps you determine, okay, maybe I don't have a rule for the ARVs, and you'll see a big red line or something show up. And so you just go in and add the rule, go back up to your network topology, validate at the top left, validate it, and then it checks off and the error is gone. And then once you have that set up, then you can start plugging your sub networks, and you have the sub network there at the top right. And then there you can find your sub network. So this would be your pressure zones, and you can do a trace on that immediately. So everything connected will be highlighted within that certain pressure zone. And then you can modify that controller. So you can add in, if you got a new PRV that was installed, you can add that in as part of that sub network. So all that's managed right there within Pro. And a kind of key component in what you see here on the map is these sub networks are displayed as this separate sub network feature class. And this is something that you never edit. It's one simple line, one row in the database. And it has all this information as far as all the service connections, all the hydrants that are part of that sub network. So you can manage that just directly through the geoprocessing tools and not have to edit it one bit. It's automatically processed when you run the update sub network. So I'll go on next to one of the key applications that we implemented, and this is bringing in several of those integration pieces, and that's the San Juan Water District water map. It's the system map that used to be a map book that San Juan Water used to hand out to their employees, but now it's a digital form. So everything in the system, again, it's a REST service, so anytime that the editors make any changes, it's immediately available to the people on the tablets. The map books, as soon as you print them out, they're out of date as soon as somebody starts making any edits on it. So in the system map, we have the distribution system, we have the water treatment plant, we have a land base, including parcels, buildings, and the CIS data, all in one application. So like I mentioned before, if the field crews are out, they have a leak, something like that happens, they can run a trace here right in the web application, identify the customers, export out a CSV of those customers, and send it off to customer service. Or if they have some of the third-party auto call system, they can set that up where it automatically notify the people that are part of that network. So you can see all the customers here, about 20 or so selected in the map, and you can keep these outage events basically saved, and then you can keep track of them over time. Okay, so we had so many happen this year, so many happen the next year during this month in this area. So you can start tracking that maintenance history over time and be able to really identify maybe where there's problem areas where you maybe need to swap out certain different parts of the system or different parts of the main line, things like that. And now I'll get into a little bit about the setup. So to do this, we have a CMMS UMS group at HDR that helped us create this design guide that was really really helpful for me and David, the district. We're trying to get everything set up with the process areas and the data, the roles and responsibilities, how people are going to be editing and using this data in the future, the difference between how we're going to design the distribution horizontal features compared to the vertical features for the water treatment plant. So there's a little bit of a different setup there. I'll say the horizontal features are a lot easier for me just because it's typical GIS stuff that's what we're used to working with. The vertical features weren't that bad. We just had to create some extra relationship classes. And I'll talk a little bit about that in a second. But we want to make sure in the GIS setup, you have a base schema that you get from Esri for the water distribution network, but you want to add in, maybe some other class-specific attributes and some other things, some other characteristics that you want to capture, and you can easily add any field you want to utility network. They just recommend don't take any away, so you can add as many as you want to it. And so what we did for anything that wasn't spatially located, we created an asset table, and we used that in both the horizontal and vertical assets. So this would be things like your electric control panels that weren't part of the water utility network that we captured as a non-spatial object in the asset table. And this is going to a little bit about where we started with. You see the diagram there at the top right is the sketch that was given to me to draw in the different systems of the water treatment plant. So this is what we started with, and we digitized these boundaries, and then brought in the different components or pieces of those different systems. So you have like then sedimentation, the different flock zones, things like that are bringing more and more detail. And once we're able to draw these in as GIS features, then the staff in the water treatment plant can just select that one simple block zone and pull in all the different information and all the different components that are part of it. And this made it a lot different from the system they used to use before. They can go back like the traditional way and pull up the sedimentation, the drop-down hierarchy. You can still do that, but if you want to go straight to the asset themselves, you basically can do that with a couple of clicks. Saves you a couple minutes to be able to do that. And there's a lot more details, like there's some more asset details that we wanted to keep. So we created these detail tables that would collect these class-specific attributes. And here's a little bit about the relationship classes and how they're set up. So you see here, again, the structure of the utility network. There's about 9 feature classes here. And really, water device, water junction, water line and probably structure boundary are really the key components. Otherwise, the other things are auxiliary. I mean, you can decide to use them in the future or not, but you can really just get started with about 4 of them, and that will get you going on the utility network pretty fast. And to model these relationships, we did a water device to structure boundary. So that would be like all your valves, pumps that are part of the pump station, go get connected to the pump station. You have the asset table that goes to the devices. So that would go maybe to like a wholesale meter. There might be some sort of radio or something like that. That would be connected via relationship class that way. And then there might be some more details that you want to include, and that detail will be connected to that asset table. That's just how we did it. I'm sure, like Scott said, you do it whatever fits your agency, but this is how we did it. And again, like I mentioned, the horizontal assets are pretty simple. There'd only be maybe one level in the hierarchy, maybe 2. But the water treatment plant had about, I think we're on 5 now, if I'm not mistaken. And again, that can be up to you on how you want to design it. And so now this is what you see on the map here, all those different flock zones within the sedimentation, thickeners and things like that, belt press system within the solids handling building. You have all that set up and mapped here in the GIS system, which then gets fed right into the Cityworks. And so you got to just check and make sure that your assets are mapped here in GIS once they're showing up, and they're going to go straight into Cityworks. And here's a little quick shot at the platform, what it looks like in Cityworks. So again, the map looks exactly the same. And it comes in via REST service, like I mentioned before. And they're using it now and working through some kinks, but I think overall they're very happy with how it's being used now, the performance and everything else. And